Rob, thanks so much for coming.
My pleasure. Thanks for having me.
So, a question I have for you is, how do you split your time? Because I noticed that you have your foot in so many different things. You're teaching at UW. You're writing checks as a venture capitalist. You're doing consulting work. You're working with big companies, thinking through the future of the bioeconomy. You have your hand in so many different pots of um, the innovation cycle. How do you think about that, and how do you split your time there?
Well, fortunately, it's not quite as busy as you just made it out to be. So one of the reasons to start the fund was that I was tired of consulting. I
Mm,
don't really enjoy the chasing jobs, chasing projects aspect of consulting. And so this was a way to use what I knew about the future to pay for me to think about whatever I wanted. And so that's working out. I'm working on another book. The time I spend at UW is mostly with graduate students and postdocs and research fellows on the DNA data storage work. And so, that's a delight because I basically get to be the crazy uncle in the closet,
mm,
and share all of the experimental experience that I have, which usually amounts to them proposing something and me telling them, trying to be very careful about telling them why I think it won't work, but doing that in a way that lays out, hypotheses for them to test and things for them to avoid. And then, 9 times out of 10, it does work, and I'm proven wrong, which is fantastic. I love that. It's the best gig ever. Um, and it also is teaching me about the future of computation and the future of biological technologies from an angle that I sort of had thought a bit about, for quite some time, and I was skeptical about. And now I'm quite convinced that it's coming, and it's coming soon, because first, it works, and second, once you start diving into the numbers, you realize we have to do something different than what we're doing now. Hard drives, solid state storage, all that stuff. We're going to run out of capacity for all the data we want to store, and we're going to run out of it kind of soon. And it's not the case that we don't know how to make more tape drives or make more solid state, drives, whatever it is. We know how to do that. The problem is that the amount of data we want to store is accelerating so fast that pretty
mm,
soon we're going to need not just a hyper exponential number of or accelerating amount of tape, but we're going to need a hyper exponential number of tape factories, and then
mhm,
tape storage facilities. And then just economically, it's totally implausible. We need to
mhm.
leap off that curve completely to something completely different. And as best I can tell, biology is what we're going to use because it does work. And we,
Mm.
not that it's ready to roll out today, but it does work. And so we're going to do it. When exactly, I don't know. It takes some investment, but we'll get there.
Oh, that's interesting. I heard you kind of describe this uh, idea with similar excitement. I watched your testimony to the Senate committee, which is a group that I've presented to before as well. And I heard you talking about this, and it got my mind racing with ideas. And it, I think it's a different future than a lot of people have imagined, or it can maybe kind of project out, and maybe that's visible in some of the science fiction that we have. What is your current, given what you've just described, what is the most kind of compelling science fiction vision of the future uh, that you've seen out there? Or is there kind of a lack of that science fiction vision in a world that you've just described?
Hmm. Uh, I'm quite a fan of The Expanse, but
Hmm.
there's not a lot of biology in The Expanse.
Right.
And so if the question is, what's the most compelling fiction that has biology in it, I have actually been quite disappointed.
Hmm.
So, there's plenty of fiction out there where lots of technologies that have to do with hard things machines, robots, whatnot,
Mhm.
is projected in an interesting way and explored in some way, but then there's no accompanying biotechnology.
Mhm.
Uh, and so an obvious example of that is Star Wars. Plenty of interesting ideas across technology, and they can't do anything about, regrowing lost limbs or other diseases. And that just seems implausible to me, because we already
Mhm.
can see that those technologies are coming along. And so I haven't seen good visions of where that might go. There are some visions of how it might go wrong that
Mhm. Mhm.
are very frequently based on entirely hypothetical fears or magic.
Mhm.
One of the challenges I think we have with biology and science fiction is that it all comes back to Frankenstein in the end,
Mhm. Mhm.
which isn't actually a very good book in my opinion. It might be a good book for its time, but it's not a good guide for the future, and it certainly isn't a good guide for what came between then and now.
Mhm.
Um, Frankenstein is basically two halves. There's striving to do something. There's the science that Frankenstein attempts to make happen. And of course, the description of it is based on what was known at the time about electricity and biology and
Mhm.
some physiology. And then there's the second half of the book, which is really after the monster is created and Frankenstein spurns the monster, or
Mhm.
after his son, as it were, comes on the scene, and Frankenstein spurs his son, thereby making a monster. It's really a different kind of a story about a bad father who's a bit of an asshole
Mhm.
and irresponsible. But in between those two halves, they are joined by a space between two sentences.
Mhm.
And all of our fears about biology, all of our stories about how it can go wrong, really is in that space. It's the absence of content between those two sentences that is the origin of all our fears, and that's kind of maddening. It's not, the stories we tell about biology are not based on a thing; they're based on the absence of a thing. And I wish we could do better.
Yeah, I know. I completely agree. And you brought up the Expanse, and in the last season, there was a short scene where Amos and uh, I forget the woman's name in the show, but they were walking through a rewilded forest area, and they were talking about this kind of reforestation effort that had happened over the past couple hundred years. And I realized, there's so many people working on this kind of this idea in conservation. Stuart Brand and Ryan Phelan being, you know,
Mhm.
two of the leaders. It's very rare to actually see. I realized how rare it was to see science fiction depicting that kind of positive. This wasn't even positive. This was almost like just a like a protopian future, just like something that feasibly could happen in a neutral or positive direction. And I thought, wow, that's really interesting that we don't see more of that. So I'm going to second your request. We need more of it.
Mhm.
So are you talking about your new book yet, or is it still kind of a secret?
Well, no, it's not a secret. I mean, I've been working on it for a while, and I will be working on it for a while. It's not coming out
Yeah.
anytime soon. I have a sort of a handshake agreement with a publisher, which
Okay.
was enough to make me feel good about going forward.
Sure.
But I don't have that'll have a home. That it sounds
Yeah.
good to somebody. Um, but I think my main goal here is to write the book that I want to write, not the book that somebody else wants me to write, which was a frustration with the first one. And I don't feel like that one came out as well as it could have, because it was kind of
Really
shoehorned into an academic press with academic reviewers, and that left me dissatisfied and was also very frustrating.
interesting. Well, I really liked it. I thought it was a great book
I appreciate that. Thank you.
at the time, and I kind of was reverting back to it over the years, and I'd go look things up. But I just actually sat down and reread the whole thing front to back um, in the past couple weeks, and it's really interesting to me because it's so Well, it was written in what, 2010 it was published. So is that right?
Published in 2010, yes, written before
Okay.
that, to be sure.
So if you think about that, it's interesting because there's no CRISPR, right? There's no mRNA vaccines. There's big chunks of this bio story that aren't in there, yet it's so directionally correct. So, and I also find it really inspiring. So what, looking back and thinking about that book, what has surprised you the most in that time? And maybe on the flip side of that, what has disappointed you? So like maybe surprised you in a good and bad ways.
Well, here's the thing that I have been disappointed by, and this is part of the investing story too, and I think we could be going much faster than we are. We could be rolling out chemicals that outcompete petroleum, outcompete petrochemicals much faster than we are. And there are two reasons why that's true. You hear a lot about how scale up is hard, and that's true. But I think we have enough of a handle on that so that if capital were available, we could get that done. But the real problem I'm finding is that the capital and the customers are slow to show up, even though the technology works. There are two fronts there. One is that when I got into this, I was feeling like I didn't want to invest in drugs or things that faced the FDA because I used to sit on a National Academy of Sciences committee whose job it was in part to teach the FDA about new technologies. That was hard. And when I thought about trying to write checks, I wasn't excited to face that part of the story with startups. And I thought it should be more straightforward in chemicals, that regulatory barriers are lower, faster to market, et cetera. And that can be true. But it turns out that big drug companies who might be the acquirers of these technologies or fund them are actually more conservative. Sorry, I may have misspoken. Big chemicals companies who might be the acquirers of this technology or fund it are more conservative than big drug companies. So if you are a small startup who doesn't want to be fully vertically integrated like Zymergen, wants to create a bug that makes a chemical and get it most of the way to market and then hand it off to somebody, that somebody is quite slow to pick it up. And we're seeing that a lot. That's a little bit frustrating. That problem could be solved by more capital added from outside the ecosystem. But then it turns out that, and this is entirely rational, I'm not saying that I don't understand this, but it is still frustrating that if you walk into a banker's office, a financier's office, a banker being a general term here, and you say, I can make this petrochemical, I can make this much of it in this big a market, and I can beat the production costs of the petrochemical industry by 20 or 30%. So I can outcompete petrochemistry economically, slam dunk. They will say, well, I can earn 20% tomorrow in real estate. So why would I give you a check to earn 20% 5 years from now or 3 years from now, however long it takes you to build out that capacity? And so again, that's totally rational, but also if we had a pool of capital that was more directed at making compounds that were carbon neutral or carbon negative even, and outcompeted petrochemistry, then we could be going much faster. And I wish that were true. I'm doing what I can, but I work on the other end of that spectrum, on the small end, trying to make the invention and innovation part go faster, the engineering part go faster. And we need more big capital to come in and support the expansion of that technology.
Interesting. Is there a particular shape of capital that you had in mind? I'll give you a little, it was kind of a leading question. What comes to mind for me is certainly you're familiar with this story of advanced market commitments and the Gates Foundation and Gavi. They pre-purchased all these vaccines, the pneumococcal vaccines, got them out to the folks in the developing world. And now that idea of advanced market commitments has been replicated with the coronavirus vaccines. But what's interesting to me is it's like all of a sudden philanthropists and, well, I guess it's just really the Gates Foundation realized they could have a really outsized impact by not just writing grants, not just investing in companies, but just being customers. And that's a really powerful driver of um, of industry. And
Mhm.
it seems like the government has figured that out, right? Like they're replicating that. They realized they could go really fast with vaccines. They had that was their best tool in the toolbox. Um, is there a role for those ideas, the advanced market commitments, in the spaces the chemical spaces you're talking about?
I think so, yes. And I like that verbiage a lot. Um, I think there's an opportunity to push the climate angle here more than
Hmm.
we have previously, because there are large philanthropic organizations out there who are now really focused on carbon, who are now really focused on warming.
Hmm.
And it might be possible to tie up a biological manufacturing story that could get funded in that way. The government is already sort of playing with this idea. There's this new Biomade Institute. It's a manufacturing institute inside the Department of Defense or chartered by the Department of Defense. And in principle, there's a pathway there for the Department of Defense to make acquisitions for chemicals like this, in part to guarantee a supply chain and guarantee domestic supply chains. Whereas today they're sort of spread out all over the place. And as far as biology goes, there could already be a large component of biochemicals that feed into the Defense Department, but because it's so badly measured by the government, we don't really know. The Defense Department doesn't really know what's coming from where. And if it's a molecule made from petrochemistry or a molecule made from biochemistry, you can't tell the difference in principle, and certainly not if it's labeled and not tracked. But nevertheless, that structure of the advanced purchases could make a big difference. I agree.
Yeah, we saw this, and we did this on smaller scales too. So my own experience was we had a bunch of philanthropists, saw we were building these low cost underwater robots. And they said, well, how can we help? Like, what can we do? And I said, honestly, the best thing you could do is buy 1,000 of these and we can donate them to conservation groups around the world. And they were
Mhm.
like, okay, it's $1 million or $2 million or whatever it was. And that's not such a crazy check in the conservation world. It's kind of like a medium sized investment. And for a lot of them to do it together, it makes a lot of sense. But we got the drones out to all these conservation groups, and the stories were incredible. And so we've replicated that, and we've done it again with coral monitoring devices. And it's amazing how it can be like a pull mechanism, like it really drives innovation in technology, but also a fantastic way to get things out into the field really, really quickly. So I think it's just a really underrated idea. And I think Stripe proved this too with their first $1 million they wanted to buy carbon capture. It's not a huge amount of money, but they were able to prototype and get a bunch of firms together thinking about it. Um, and I think it's hopefully, especially after the pandemic and the experience there, I think hopefully this government as buyer idea gets real traction, and with philanthropists too, because I think it's so far we have really good examples of it working big, small scales, and across disciplines. So I'm hopeful about that.
Just before you go on, I think we could do a
Yeah,
lot more with prizes as well.
yeah,
But the thing you identify is working capital. So it's
hmm,
one thing to be able to win
hmm,
$1 million prize or a $10 million
yeah,
prize or whatever that number is. But where do you get the money to build the thing to get there? And the advanced purchase agreement could make a big difference to many of these companies, because that could be partially funded up front and give them some working capital. But then that's also a proof point to raise more money. If I have the ability to make this thing, I have a buyer for it. Now go raise money on I have a buyer for it, rather than on simply, I believe that if I make this thing, somebody will buy it. And that's a lot harder story.
yeah. It's powerful, and it really does move industry, and it moves small firms who like startups who kind of have some flexibility to scope out new markets, but it also gets the attention of some of the bigger players. So I think that's a really underrated idea. So kind of just to recap what surprised you, it sounds like things are, it's almost like a frustration with things not going fast enough. Um,
The technology has moved quite quickly. There are, anytime you try to build something, you run into hiccups. And so those hiccups
sure.
are out there, right? We had as an explicit hypothesis when we started Bioeconomy Capital that we would be building out design for manufacturing for biology. So the same infrastructure that gives you an airplane or a phone, you design a thing on a computer, and that software knows about manufacturing and can develop processes all the way along, so that there's sort of a closed loop design, build, test cycle there, and it's all mediated by software, the tool
Mhm.
chain. That was explicit at the beginning, and that's working. And also, it's slow, and adoption is slow. Uh,
Mhm.
so even though the tools are out there, Riffin has been available as a tool to do much of that for years now, and now they're finally getting traction. But
Mm.
those lean times between when you can stand up and say, "Hey, here's a thing that works to solve these problems you have," and these are billion-dollar problems that can just go away with a software package, right? You can
Mhm.
save someone $1 billion tomorrow, and it takes them 2 years to sign up for that. That's hard. So
Yeah.
that part's, it's good that the tools are there, and also it is frustrating that adoption and capital are moving slower than I had hoped.
Yeah, it's interesting. I know the feeling because I had the same experience with Ocean Tech. We kind of, started building something in our garage and then put it on Kickstarter and, saw this adoption, and all these kind of traditional academics and traditional Ocean Tech folks were kind of looking at it going, well, how are you doing that? And so it was like, don't mistake the clear view for a short distance, right? Like getting these kind of bigger industries to actually get on board and to really change things. It seems to always take longer than you think it's going to take, which is unfortunate because some of these challenges that we have, we actually do have to move faster. Is there anything on the positive side that surprised you?
Well, again, the tools do work. I
Yeah.
thought a lot of that stuff came to fruition much faster than I was expecting.
Hmm.
Um, at the beginning, there was a story about retrosynthesis and about being able to make not just everything in a barrel of petroleum, which I had seen elsewhere in my travels. I was pretty sure that was going to work out, but I didn't know when. But then also the ability to make stuff that didn't exist. Now enzymes are magic.
Hmm.
Unit chemical operations in the form of enzymes are truly amazing. And because we can design those, I say we, not that I'm doing this, right? But there are
Hmm.
people out there who can design enzymes to
Yeah.
make new chemistry happen and
Hmm.
put those things into chemical pathways. You can make compounds that have never existed before and that have properties that are far superior to anything you get out of synthetic chemistry, and do it from a renewable resource,
Hmm.
so that the whole process is at minimally carbon negative. I mean, minimally carbon neutral, but possibly carbon negative, depending on how we do this. I thought that was going to take longer, but it works today.
Hmm.
So you can churn out these new compounds. More importantly, I think I would say that it is also clear we could make it go even faster than it works today. So, Zymergen S1 describes a particular pace and cost for getting new chemicals out the door. I know we can go faster than that because I'm seeing it in other companies who just don't have the same public visibility as Zymergen does. So
Hmm.
there's a huge amount of optimism to be had about the future. Um, and I want to go faster.
Yeah, I know the feeling. Okay, I'm going to tell you a short story before I ask you the next question. I You had a bigger influence on me than you probably know. I
I'm
saw your
sorry.
photo. No, it's has been for the best. So I remember on Kevin Kelly's blog, he had some initial photos that you had taken of Ari Gentry's garage. Do you remember that? Like
Yeah.
the kind of the first garage biohackers. And I reached out to Ari and became friends with the whole BioCurious crew and helped them launch their Kickstarter project. And it was actually Josh Perfetto who started Chai Chai Bio, who introduced me to Eric Stackpole, who then we started this underwater robot thing. So those photos that you took, and that, more importantly, the story that you told around what was coming and what was possible in that realm. Like, these tools could be cheaper. We could have this kind of garage innovation ethic in biology. Got me excited. It kind of painted this possible future. I also think, also your book, I mean, you have, I think half the book is a biology book, and, you know, half of the book is really a story about innovation. And you talk a lot about some of the parallels between these different industries, you know, whether that's aviation or computers, but you also talk about the real seeds of innovation, which, you know, sometimes, whether that's open source, or, you know, creating these kind of commons and standards that people can build on and can run with. What is your current opinion about this kind of movement towards open source biology? Do you think it's a more important idea now than you did 10 years ago, or less important idea, or is it still, we'll wait and we'll have to see?
That's a great question. And it's a timely question, because we can now see the impact of some of that stuff on the response to the pandemic.
Mm-hmm.
I would broaden it beyond open source to make it about democratization and access broadly. Open source has a, you know, particular technical meaning when it comes to software, and it's way too easy to forget about the technical constraints that make it work in software and assume that it works elsewhere. So
I learned that lesson the hard way with open hardware. Turned out, like, we thought it was going to be a copy paste from software. Turns out it's a whole different thing. Anyways.
Yeah. And so open source biology sounds like a thing, but it's not actually a thing, because, you know, for example, you don't have the same mechanisms to copyright content as you do in software as an alternative to patents, which is what makes open source software work. But taking it back to that broader story about democratization and innovation and garages, if you look at the high throughput testing that's being rolled out around this country, but now also in other countries, you can see hardware being employed that came out of those garage labs or out of community labs. So Opentrons started in New York in a community lab, and the Bento Box, the Bento Lab, started at iGEM and then went through a community lab in London. And that's now a tool that has been deployed, or at least been described in an application that allows you to do high throughput not open source, but open access testing. And Chai Bio has their own angle using PCR to do high throughput testing. And for years, when I would go to DC or Geneva or London or whatnot, I would get this, or Tokyo, I would get this pushback, you know, garage biology can only be bad. We don't want people to have access to these tools because it will only end in misery and woe, with no data to support that story. And in my mind, all of this, again, goes back to the space between those two halves of Frankenstein, where there's no actual evidence that any of this will be bad. It's all hypothetical. It's all hypothesis. And what I could do was, at the time, and for the last 20 years, point to other industries where not only had this worked out okay, but it required that sort of democratization. You know, computers, electronics required that kind of democratization. Aviation went through a garage. Every technology in our economy that we consider important went through a garage at some point in its development cycle.
You know, there's a great Make article from Michael Schrage called "Kits and Revolutions," and he's like, we haven't written the great book on kits and amateurs, but it needs to be written because it's such an important and powerful part of the process. Sorry for interrupting.
Yeah, no, it's okay. And for years, all I could do was push back and say, you have no basis for your fear. it's just fear. Again, it's that absence of content in Frankenstein that's driving all of this stuff. That's my version of it anyway. And now today, I can say, hey, look, we have this public health emergency, and part of the response that developed and the speed with which it developed, at least in certain instances, is entirely derived from that garage innovation. And that's a fantastic story. So as it happens, I'm trying to finish off a paper for Nature Biotech that is an argument about reevaluating these judgments of garage innovation and garage biology. And now I'm delighted to have these examples where I can say, hey, look, and I would love to also in that paper to say, I told you so, but I won't do it quite like that.
It's interesting because I had the same inclination, because I'm looking around. I pitched this to Make. I was like, you know what you should do? Where are they now of the garage biologists from 10 years ago? Because I'm looking around Josh and Ellen Jorgensen, who was involved in GenSpace. I mean, they're and OpenTrons and all of these projects are really involved in the pandemic response. And I look at Tito Janikowski, who was involved with Josh to create the original OpenPCR. He's leading the air miners, the carbon capture work. He's partnered with XPRIZE and Elon to launch more companies into that space, and is kind of pioneering that world. And I could go like on down the line of the other people at BioCurious who then got into the cellular agriculture work that's now creating the Beyond Meats and all of these things. And all of these people have incredible stories and have made wonderful contributions. And yet, anytime you go back and you look at any article that's written about garage biology over the past 10 years, it's got Josiah Zahner injecting himself with CRISPR, and that's the only story that they want to tell. And it's really unfortunate, because there is a really wonderful story underneath that kind of catchy headline, and it really bums me out.
It sounds like you have a book to write too.
Oh, I don't know. I think it's just I just think it's a simple where are they now, and just kind of showing it, saying like, look at all the important work that's come out of that.
You say simple little story, but that's how those books get started. I tell you.
So, speaking of that, you dusted off I saw this on Twitter, you dusted off a proposal about investing in this idea of community biolabs around the country. Can you talk a little bit about that proposal that you wrote, when you wrote it, and how it might be applicable now that there's this huge infrastructure bill?
Well, that goes back to 2008 or 7 or somewhere in there. And there was a request put out, I guess to me specifically, for some ideas about how to improve biosecurity and also improve the ability to innovate in biology. And so my response was this public-private partnership for community labs, where I was trying to solve a couple of problems. One is biology startups are hard and they're expensive. You need lab space. So a garage is kind of a hack on startup space in that sense. When I had my garage lab, which I think I put together in about 2004, I don't know I'm sure I wasn't the first, and I wasn't the first to have to solve these problems, but there's, like, where do you get your water from, your pure water? Well, I wound up having to order it all the time. I didn't have a cheap filter. And then what do you do with your waste? And I had to be innovative there. And, how do you get stuff delivered to your house? Again, this is after 2001, and the FBI is going nuts and arresting people for doing stuff like that, even though it was perfectly legal. So then there's another problem I was trying to solve, which is how do you build a better interface between the government and innovators, where the government is scared of what the innovators are doing, largely because the government doesn't understand what the innovators are doing. And there's some stories around the FBI's behavior in the early mid 2000s, that really are about them not having any idea what was going on and just reacting badly. That part of that has been fixed a bit. Ed Yu famously at the FBI created an outreach program to connect people who were in community labs or unconventional settings with local FBI agents, so that they could communicate and know what was going on. But I also think a centralized place where
Mhm.
the FBI can go, basically do a rotation, or at least know what's going on, or have a point of contact.
Mhm.
And then it's not just the FBI; it's also local law enforcement, whatever. Because there is this fear based in misunderstanding. Let's get rid of the misunderstanding. Let's
Mhm.
educate both sides about how the process works, both in innovation and then also the process works in law enforcement, so that we can avoid stuff like that in the future. Um, but then, what are the longer term implications of something like that? Well, now we have an infrastructure play to facilitate biology startups, and that's local jobs, that's local economic development.
Mhm.
Um, Typically, these things are called incubators, and they're often funded by with commercial intent by, say, a VC firm or something like that. And the first time I looked at the economics of that was before 2000, and I couldn't make the numbers work. It looked really hard to me to make an incubator fly as an economic activity.
Mhm.
And I think that's still true. Um, and so they ought to be loss leaders. That's an important part of this proposal. I think they should be government funded because it provides infrastructure, provides jobs, and because it provides this interface with the broader community and with government and with law enforcement. It makes perfect sense as a loss leader. This is an investment in communities. It's an investment in the future. It's a way to facilitate economic growth, and also to train people, because the when the community labs work, one way they're economically viable is through classes. They're
Mhm.
teaching people to do all kinds of different stuff in those
Mhm.
shops, uh, which indicates that people want to learn. Uh, they want that access to knowledge and that access to being able to learn a new skill, being able to, envision themselves in that garage biology startup and then
Mhm.
go do that.
Yeah, I completely agree. And this happened, right, with the maker movement, where there was this kind of explosion of maker spaces, but they all kind of struggled to find this economic model. Tech Shop famously kind of, went bankrupt. It should have been underwritten by cities, right? Like in federal government, because it was such a magical place. I wrote a whole book about just how special that 2011 2012 period was at Tech Shop in San Francisco, because so many people like us were wandering in there, getting access to tools for the first time, um, but more importantly, getting access to people, right? Learning how to use the different tools, learning, sharing ideas. Kickstarter had just become a new tool for us, so we're all raising money and getting projects going. I think it's hugely underrated, um, and it in the maker movement, it kind of burned out, right? Like in some ways, like that amateur enthusiasm didn't it was almost like a wave, and I've been thinking a lot about the reasons for that. And you go and you look at the kind of the history of these exciting waves of innovation in computers, and they seem to actually happen in waves. Like now there was the internet, and then there was web 2.0, and now they're talking about web 3.0. There's these kind of crests of optimism and excitement and a mixture of new tools and people, that happen. Do we need a DIY bio or a garage bio 2.0 movement to happen? Do you see signs of that? And what can we do? If not, what can we do to instigate it? Should we instigate it? What do you think?
Well, I think it's probably bubbling along under the surface. Again, the tools that are available today, and whether it's Opentrons or the Bento Lab or whatnot, um, the ability to share information. Um, we could do a better job of facilitating access to raw materials, reagents, stuff like
Hmm.
that. There's, again, this fear of allowing amateurs access to CRISPR or something,
Mhm.
uh, which leads to restrictions or fear of allowing people to have access to synthetic DNA. So in California right now, there's this proposal to there's legislation to require sequence screening of all companies that operate in, of all sequence providers, I guess, that operate in
Hmm.
California, or might even be all customers. Or maybe I can't remember the details now. Perhaps it's state money. In any event, These are built around the fears that people with access to these new tools will do nefarious things. And so I think we could have a different focus, which is on the opportunity rather than the fear, and to lead with that opportunity rather than sort of seeding the conversation to the fear.
Mm-hmm.
I don't know that Josiah helped his case by being so flamboyant about it. If he had just sold reagents to the world, he might have a thriving reagent business. And he chose a different path. And I don't know what shape his reagent business is in, but he certainly brought a different kind of attention to himself and his operation by being flamboyant than if he just sold stuff. And then also, maybe he could have collected those stories of success and packaged those up as a way to demonstrate that it was just fine to do this. I think the economic pull on all these technologies is absolutely enormous. The revenues from biotech in the US and across the globe are already very large and are growing rapidly. The pandemic demonstrates the importance of focusing on understanding biology and treating it with respect, whether it's in the garage or in the wet market or out in the field, wherever that virus came from. And now we have an opportunity to have a different conversation about it. And so I'm excited by that. I'm excited by the ability to expand the conversation to, we live around biology, we are biology, we eat biology, we need to understand it better. We need to treat the biology that's out in nature with more respect, which means understanding it better, not trampling on it, not putting ourselves in situations where we're exposed to threats without knowing what the hell's going on. But then also recognizing that knowledge is an opportunity to do better within the economy, and bringing what we learned from ecosystems back inside. So one of our investments is in a company called Upward Farms, and they're basically ecosystem engineers. It's an indoor farm, but rather than grow one crop, a monoculture, reinforced with intensive chemical operations, just like a monoculture is out in the field, they're this polyculture, bacteria, fish, plants, different species all together. And it turns out when you pay attention to those interactions, you wind up with a more productive, more stable, lower cost manufacturing system. And those lessons were available by looking out the window this whole time. But not everyone is willing to learn them. And I hope now maybe the lesson is becoming clear that we have to pay more attention.
Yeah, definitely. So I've been doing this Science Better series because I started it because I noticed the open science world, which has been going for, whatever, 10, 15 years, and the citizen science world. To me, 10 years ago, all of this was connected. The DIY biospace, it was a bigger vision for science, something that was kind of out of the ivory tower that allowed a lot of people to participate in and contribute to, but also understand. And all of these kind of groups, now I look at them, and open science is just arguing about definitions, and it's kind of plateaued at preprints. And I'm on a thread right now at the citizen science mailing list where they're just arguing about the definition of citizen science and should it be community science or citizen science? And it's like, we've kind of lost that, the bigger vision, I think. And you and I have been talking about the power of biology and where that could go. And I've been asking everyone what their specific recommendation is to make science better. And you've given me a lot of good ideas so far, but do you have any ideas along those lines of the way we can improve the scientific enterprise?
Well, that's not a small ask, is it?
But everyone seems, every time I ask it, people seems to have like a really specific thing that they've just been harboring. So do you have one of those kind of pet projects?
I don't know. We'll see if I get there. I think I want to respond first to the idea that there's a recent birth date for citizen science or open science. You know, the Royal Society started centuries ago with a bunch of amateurs who were playing around
Hmm.
and sharing information uh, in a journal and writing up what they did, trying to systematize their knowledge and spread it around and get some credit for that. You know, one of the notable exchanges I came across when I was reading about the early history of aviation for the first book was around patents, the patent story, the patent struggle between Octave Chanute and the Wright brothers.
Hmm.
And their very first description of that was patents. There's going to be no economic value here. This is just about credit. We just want to show that we invented this thing. Of course, the conversation changed when suddenly there was economic value to be had, but nevertheless, there's another example of a bunch of amateurs trying to make something, and initially anyway, sharing that information as broadly as possible, also wanting to get some credit for it. And so I don't see it that different today. We have a bunch of people running around trying to invent stuff, trying to learn, trying to make the world a better place. Some of them want to be, you know, more out front in the press and receive more credit, or, you know, are interested in performance art of one kind or another. And others just want to build stuff. And so let's help them build stuff. There is a difference today in that there's a priesthood of science, and the priesthood thinks that only the priest should get to do science and bestow the ability to do science on other people they deem worthy of being priests. I don't have much use for that myself. And, you know, the priesthood exploits the same kinds of language about fear and control in science as the priesthood has in other areas over history. Not really excited about that either. I don't think that helps the public understand what's going on, or helps new stuff, new tools, new products come to market any faster. And in fact, it slows it down, I think. So what I would love to see is more people having more access to more capability. And if the pushback to that is, as it has been for decades, is, but they might do bad stuff, then okay, they might do bad stuff, and we should be prepared for that. But you know, we just had a bad thing happen, and as best I can tell, it didn't have anything to do with humans, other than humans
Hmm.
stumbling around picking up a virus because they weren't, you know, they were in a place where they were exposed to a virus that was naturally evolved. That story could wind up to be something different, but I don't have any reason to believe that it is different at this point in time. And that's pretty bad, you know. And if you're proposing to me that a teenager in a garage could come up with something that is even a small fraction as bad as this thing we've just experienced, I'm just going to laugh at you, because I've been in the garage and I know how hard it is to make stuff that works intentionally.
Hmm.
And even though it's getting easier, it's just as hard to do something good as it is to do something bad. And the people who want to do something good have light, they have sunshine, they have the ability to cooperate and communicate. And the people who want to do bad stuff have to hide it, and they have to do it all by themselves. And that makes it harder. And we need to go faster. We must have new technologies to step away from what we have relied on so far. The 20th century was built on burning stuff and digging holes in the ground. And this, by definition, is not a sustainable activity, because we're just mining stuff.
Hmm.
We're not creating stuff. We're not investing. And now we're paying the price for that. So we have to have new technologies that are sustainable, that allow us to renew ecology instead of mining the seed corn, you know, from prior investments. And I think the best way to do that is for more people to innovate. So that's, if I have an end to that, it's let's have more people doing more stuff.
Go here, here. I like it. I like it. Well, I'm really grateful for your time. I continue to be a big fan of your work, and I'm now eagerly awaiting your next book. So Take your time.
Please be patient. Please be
Yeah,
patient.
take your time. As long as you continue to share and update what you're learning, I think that's equally important. It's, you know, writing about these topics is tough because they're changing so fast. And but it is important that that vision of the future gets out, because you don't know who it's going to inspire, right? And then who it's going to, like me, show up and meet Ari and then meet Eric and start an underwater drone company and go from there. So it's important that you communicate these ideas along the way, because we're all relying on it. So Rob, thanks so much for your time.
And thank you.